In today's topic, we are going to see about tachometer. What is tachometer and what is the use and purpose of tachometer? Generally, tachometer, which is used for measuring the rotational speed or angular velocity of the machine. That is what tachometer talks about. The tachometer principle is about there is a relative motion between the magnetic field and the shaft of the coupling device. So whatever the relative motion which induces the EMF in the coil which is placed between the permanent magnet. So the EMF produced is directly proportional to the speed of the shaft. That is what the relative motion between the magnetic field and the shaft of the coupling device. So how this relative motion is getting produced, the EMF, and how the magnetic field is generated, that is what we are going to see in the tachometer operation. So there are two different types of electromagnetic tachometer we have. The tachometer we can also call tachogenerator. There are two different types. One is DC and the another one is AC. So in AC tachometer generator, we have, this is what the coupling device, the shaft, the speed, what we are going to measure. We have a permanent magnet, that is your north and the south, and which connected to the commutator. Out of this, that is both upper and the lower, we have brushes, and those things were connected across the resistance. The resistance which also connected to the moving coil voltmeter. So due to this commutator brushes, there will be an EMF induced, and moreover this DC tachometer working on the principle of when the closed conductor moves in the magnetic field. So whenever the conductor is getting moves in the magnetic field, there will be an EMF. That is what electromagnetic induction principle. So the magnitude of the EMF depends on the flux linkage with the conductor and the speed of the shaft. So we can see the working, how it created. So the working is about when the armature of the DC generator revolves. That means if it gets rotate between the field of the permanent magnet, the rotation induces the EMF. So that EMF is proportional to the speed. So here the commutator work. What the commutator will do? The commutator which convert AC to DC and also with the help of the brushes. So whenever the moving coil voltmeter measures the EMF, the polarity of the voltage determines the direction of the motion. Because the conductor which also consisting of the rotating, so when it gets rotate, it automatically directly connected to the brushes component. The brushes will also getting revolve. So due to the revolving nature, there will be a change in EMF. The polarity is also going to change. And we have connected the resistance connected across with the voltmeter. So whatever the function, the induced voltage which happens, that we can able to see it in your voltmeter. So the EMF induces in the DC generator is given as E is equal to Pn phi into Z divided by 60A. So here this phi is induced magnetic field strength, P is number of poles, N is number of turns, then is that N is speed in RPM, revolution per minute, is it the number of conductor in armature winding, and A which is number of parallel path in the armature. So directly we can say your induced EMF is directly proportional to the speed. That is E proportional N. So that proportional we are just multiplying with the constant K. So finally you will have the equation E which is equal to K into N. And K which is replaced with pi PZ by 60A. Then what are the advantages when you are talking about this DC tachogenerator? The polarity which indicate the direction of rotation, and we can also identify the induced voltage using the voltmeter. The disadvantages, here we have a commutator and the brushes, so we should have a periodic maintenance is very important. Then the output resistance is kept high as input compared with the input. So to avoid there will be some distortion of the permanent magnet. The next one is about AC tachogenerator. What is AC tachogenerator? AC is the problem due to commutator and the brushes of your DC that will overcome by this AC. And AC we have a stationary armature. So because of stationary armature and the magnetic field is getting rotated. So there is no need of commutator because the previous one in DC it needs a commutator and the brushes. But here it's not so because the armature is stationary and the magnetic field is getting rotated. So there is no need to go for commutator and the brushes. The principle is the rotating magnetic field induce the EMF in the stationary coil of your stator. Whatever the amplitude and the frequency, it depends on the induced EMF. So you have a permanent magnet which is coupled with a rectifier. This component is bridge rectifier which consists of diode. Okay, so these two have equal. And here one more thing is like positive negative. Then here this pointer we used to represent positive and negative, positive negative, positive negative. Then we have a positive, and this bridge rectifier which is connected to the resistance with a smoothing circuit across moving coil voltmeter. So here also the speed of rotor. The speed of the rotor is measured by considering the amplitude of the induced voltage. So whatever the induced EMF which was present in this particular generator, they are rectified using the rectifier. Then it is smoothened by the filter circuit. So smoothened in the sense it is nothing but whatever the noise which was present inside that will getting reduced due to using this filter. The advantages is it will generating a ripple free output and the cost is also very less. But when you are talking about the disadvantage, it gives a non-linear between the input and the output when the rotor get rotate at a higher speed. So you will get a non-linear action. So that we can't able to avoid in your AC tacho generator. So that is what about AC and DC principle, working, operation, advantage and disadvantages. Now I would like to show you how the due to magnetic field generating, how the EMF is induced. So we can see now using this particular video. Just look at this diagram. So how it gets rotates. The input is in mechanical energy. The output you are getting electrical energy. So what's happening here? There is a magnetic flux. There is a magnetic flux and the magnetic flux and we have a conductor. So whenever the magnetic flux is associated with the conductor, then there will be a change in EMF. So the EMF is induced in it. Due to that, because it is in closed loop, so there will be a current flow. So the bulb is getting glowing. Then now look at here, there is a permanent magnet S and N. You have a brushes and this part is called as a conductor. So what will happen? The conductor which is in between the permanent magnet, then automatically there will be an induced EMF and which was connected to the split rings and which is connected to the brushes. So due to that there will be a dynamically induced EMF. So the operation of this is based on dynamically induced EMF. So according to the rotation, you are having the waveform. This is what your DC current. But how the changes of the split rings connected with your conductor? So you can just look at here. When the conductor is getting revolves, then automatically the polarity which was connected to the split rings is also going to change. So that is how we are getting the AC current. So this is how single loop AC generator is working. So whenever the revolving motion, either it is in AB portion or is it in DC portion, accordingly the split ring is also getting changed. So whatever the changes on the conductor part, then automatically that will indicated in your voltmeter. The voltmeter which was connected to the resistance across with your split rings. So whenever the magnetic field is cutting in the conductor, then there will be an EMF induced, right? So such current undergoing periodic directional reverse is known as alternating current. That is what we have seen in the previous one, the AC current. You are having both positive and the negative. So that is only because of the revolving nature of the conductor which was present inside the magnetic field. So the split ring, that is split ring, it's like in cylindrical nature. There is an hollow and this is called it as in segment. Both two segments are there, A as well as B. In between the black one is in mica, and the components, that is both the segments A and B, which was connected to either side of the conductor, and the conductor which was connected to the brushes. So there are two brushes on the left and the right hand side. So the A segment which is connected to the left side and the B segment which is connected to the right segment. You can just look at the diagram for the A segment which was connected to number 1, B is connected number 2, and A is connected to AB component and B which is connected CD, and also the polarity positive supply which was connected to A and the negative supply which is connected to the B component. So if there is a change, there is a revolving, then automatically both A and B will get changes. So if B and A change, then automatically the polarity is also going to get changed. Now you just look at the B and A is getting reverse and AB is also getting changes in C and D portion. So both positive and the negative polarity is also changed. So likewise, you will get the output response using this particular DC generator. So the general principle of DC generator is your mechanical energy is getting converted into electrical energy. So the current is unidirectional, but it is not continuous. Unidirectional in the sense either you will get a positive or you will get a negative portion. Yes, this is how the working of DC generator works. So the output you will have only DC. So if you would like to go for AC, then we can have both the polarity